Hello, and welcome to today's lesson on convection currents. This is for the 8th grade middle school standard Earth and Space Science 2-6. The essential question for today's lesson is, how does the sun's energy drive convection within the atmosphere and oceans, producing winds and ocean currents? All right, so we've got some vocab words with this lesson, not quite as many as the last one. And we have a couple that are repeats, but we have convection currents, ocean currents, global winds, local breezes, cyclones, which include hurricanes and typhoons, thunderstorms, high pressure, low pressure, and wind. We'll be doing some notebook pages in class for all of these vocab words. All right, so convection currents. What is a convection current? You know that a convection current is the heat energy transferred between two parts of a fluid of different temperatures. We talked about convection currents a great deal in regards with plate tectonics. So when hot fluid rises and cold fluid sinks, it creates the convection currents. We have 3 different places on Earth where we have convection currents. It happens in our atmosphere, in our oceans, and within our Earth's mantle, which we mentioned has to do with plate tectonics. It can also happen in a pot of soup or in boiling water with rice. We've all seen these before. So this slide here is talking about Earth's convection currents within the mantle. We know that the convection currents flow within the mantle and cause plate tectonics. And we know that less dense magma moves up, and that's the hotter magma, and that the cooler magma moves back down. And this forms the circular motions of the currents within our mantle, which drives plate tectonics. Now, this same type of action happens within our oceans. So our oceans have different convection currents. They're all related to the temperature of the water. Ocean waters are heated by solar energy, so light and heat from our sun influences the temperature of the water, and also the salt content, which can affect the density of the water. Those two things together create our ocean currents. And just like with our tectonic plates and with magma, and we talked about it with air masses as well, more dense water sinks. And conversely, less dense water rises. And so because of these actions of more dense sinking and less dense rising, we get currents, convection currents within our oceans. We also have convection currents within our atmosphere. Just like with the ocean, the heat comes from the sun. So what happens is the sun heats up the Earth's surface. So the sun is heating up the land. That heat is then transferred to the air by conduction. So sun heats up land, land heats up air. So the air touching the Earth's surface expands because we know that when it gets warmer, the molecules move a little faster, it starts to expand, it becomes less dense. Less dense things rise up, more dense things sink down, and we end up with convection currents within our atmosphere. This graphic here just shows you've got cooler air sinking down, causing surface winds. Air starts to warm up from the heat coming off of the land. The warm air rises because it's less dense and it cools off, and the circle repeats itself. All right, now when we were talking about air masses, we talked a great deal about high and low pressure systems. So if you remember, a high pressure system has the cool air masses, they become more dense and they sink towards the earth. Low pressure, as the air masses warm, they become less dense and rise above the earth. Again, high and low temperatures of air are what cause the convection currents in our atmosphere, and they create wind. We've seen this graphic before in terms of high and low pressure, creating the wind, which moves from our high pressure areas to our low pressure areas. Now, within our atmospheric convection currents, we've got a couple of different types of things that are going on. There are global winds. There's a graphic there, picture number A, shows how the winds are blowing across the planet as a whole. Global winds are things like the trade winds that you've heard of, and these are global weather wind patterns. So, but there was also local breezes, and we're going to talk a little bit about the different categories of local breezes and some storms that can come up because of the convection currents within our atmosphere. There's a picture here of a cyclone, and cyclones are either hurricanes or typhoons. And there's only a little bit of a difference between the two, and I think that that will be the bonus question on this quiz. And the other thing that we can get due to our convection currents are thunderstorms. So, the first thing we're going to talk about are our local breezes. There's a couple of different kinds of local breezes. We can get a sea breeze, which, as it sounds, is a breeze that comes in off of the water towards the warm air. During the day, this heat from the sun heats the land up more quickly than the water, so you've got a little bit of a temperature difference between the two. The cool air comes in, the warm air goes out. Now, the opposite of our sea breezes is a land breeze, and we tend to get these in the evening. You see in our little picture here, the moon is out, and what's happening here is now we have a breeze that's flowing from the cool air above the land, which is a high pressure area now, towards the warmer air, which is over the water. We know that during the day, the land heats up faster than the water does, but at night, it cools down faster than the water does. So during the day, you get breezes that come off of the water, and at night, you tend to get breezes that come off of the land heading towards the water. So we also get convection currents caused by mountains and valleys. So when you have a valley in between mountains, during the day, the surface of the mountains heats the air up higher in the atmosphere more than it does or quicker than it does down on the valley floor. So you end up with warm air up high and cool air down below. This attracts the air from the valley, creating a breeze that blows from the valley floor up to the top of the mountain. So think of it as a wind that's almost going uphill up the sides of the mountain. And just like with the land breezes and the sea breezes, with the valley breezes, at night it changes and you get the mountain breeze. Because in the evening, the slopes cool the air more quickly than they do lower in the atmosphere, which changes the direction of the wind flow. I know this is a little complicated, but if you always remember that warm air rises and cool air sinks, you'll be able to figure out what the different convection currents are. So now that we've gone through this entire lesson, you want to be able to make sure that you can recognize that the sun provides the energy that drives the convection currents within the atmosphere and the ocean, which produces winds and ocean currents.